Okay, so we stopped around this point yesterday, so we'll continue from here. So what is a file? A file is some information or data which stays in the computer storage devices. It can be any form. It can be music. It can be text files. It can be video files. So any file, images, everything is a file. So text files are simple text, and binary files contain binary data which is only readable by the computer. Okay, I think just a sec. Can you see now? Okay. Okay, let's continue. So, what are the? So I just read out these two, this slide. So we'll continue from here. So, what is file handling? Um, you create a file. Okay. So you create a file, you open a file, you read from a file, you write to a file, you close the file. So basically, these are the five operations you usually do in a file. Okay. Now, opening, reading, writing, and closing. You can, while reading, you can read the entire file, or you can read your particular lines which you want. Writing, you can write many things. You can write number, you can write a string, you can write line by line, and eventually you can close the file. So these are the basic steps you can do. So let's start with a simple program here. So if you guys can open your Jupyter notebook. So just write some 2 3 lines of code here. So I'll just explain you the code. So open is a Python command. Okay, so open this file. This is the name of the file, and you are this W means whether you want to write it, or if you put it as R, then you want to read it. So writing means you can edit the file. Okay, and reading means you just need to read the file. Okay, so for example, when you open the file, so and when you're opening the file as a Python object, it is storing in my file. Okay, so mcal dot text is the file name. I'll just tell you, don't execute the statement right now. I'll tell you how what to do, and then you store it in this my file object. You do a myfile dot write where you write this text. This backslash n is basically you want to change the line. Okay, and then myfile dot write second line is again you write this and you change the line. Okay, so first of all, just do this: import os and os dot get w, get cwd. What it means is os is basically a function which is used for getting to know the working directory on which you are working. Okay, so for example, you have just import this and run this command. So get cwd means it's get current working directory. Okay, so just execute this. Has everyone done? Let me know with a yes on the chat box. Okay, thanks, Sunil. I did. Can you see this line? I mean, it will be different for uh, you guys. So this is where your current working directory is set. Okay, so this is where you whatever Python will be accessing, the files should be stored in this particular working directory. Okay, now just go to this documents. I mean, whatever file it is mentioned, just go there and create a notepad. So for example, I'll go to my documents. Okay, and I just create a file called mcal.txt. Is that done? Just create it. You need not, enter anything. Just create it as a text document and just minimize this. Okay, thank you. Okay, now just execute this statement. Okay, make sure whatever letters you have written, you write the same letters here. Don't make anything capital or small other than what it is there. Just execute this. Is that done? Is it done? Give me a yes. Okay, so I presume everyone has done this. So for next, you execute write this line of code. My file dot write, and you just first write this, and then my file dot write second line, and then you so these here you have done all your writing operations. Okay, now you do a reading operation. Reading means you just need to read the file. Okay, so while you open the file, okay, this is the text file. You're giving it the r r is the tech like what we had here is W. It's for write. It R is for read. Okay, so you just put the R here, and then for line in my file for each line. So Python is very intelligent and very powerful. So it will understand that whenever we are going through the file, okay. So for line, it will understand that uh, line is one of the parts of that my file. So my file is a text file, and line is going through each of the lines in my file. Okay, so if you want to say, let's say if you want to access each of the words, okay, what to do then? For example, I'll just show you here. Okay, first line is very okay. So you see here you get first line is very important. So I just run a line for example your cursor when your Python program is starting, so your cursor will be on your first line. So first line is very important, it will print it, and then it will move on to the second line it will print it. Now for example you want to access the important this word, okay, or you want to access very. So what you will do, you'll just do for word in line, okay, print word. Okay, so I'm not executing this because it will again give the same and redundant printing. So just to give you the essence, so Python will understand my file is made up of n number of lines. So whenever I start a loop, it will execute, it will go through each of the lines, and then word is and a line is a particular line is a combination of number of words. So for when I do this, so every word will iterate, I mean word will iterate through every word of the line. Okay, so you get this. Any doubts here? Okay, that's good. Okay, so we did this. Reading, writing, closing. I mean, close is just a function, so you need not do. I mean, you need not write anything on this. So you have done this. Okay, now we have completed this. So these are the exercises. I'll just uh, go through it once. Write a program to write 6 lines in a text called hello.txt. So hello.txt is a file. So I mean, you just need to. What you need to do is, for line in my file, just keep a counter. Okay, so for example, you start with I equal to 1 for line in my file, and then I don't need this. So print line. Okay, and then you just need 6 lines, right? So after this, what you do is I is equal to I plus 1. Okay, so every time you read a line, the I counter is incremented. And then if you remember, we did a break function. So if I equal to 6, right? So you have already so 6 will be there, so 7. If I is equal to 7, then you just want to break the loop. Okay, you have already printed 6 lines, 1, 2, 3, 4, 5, 6, and then after 6, when so what you can do is, you can either you can keep this at 6. Okay, or you can have this at 7 and print the line inside the loop. Okay, so what you can do is, you can, if I equal to 7, break, else, print line. Okay, so it's a simple use of the break statement that we discussed yesterday. We normally don't use it, but I mean, in such cases, it's a very important or powerful tool to have this in Python. Okay, so we'll continue from here. Write a program to count the lines in a file. Again, very easy. You just need to run through the loop, keep incrementing I, and then come out of the loop after the loop finishes, and then just print I. Right. So, any doubts still here, or should I show? Okay. So I think this is intuitive. I didn't print first 3 lines, last 2 lines. So these are very easy. Write a program to find total number of words in a file. So I already told you. So for example, if you want to access each word, so you do first access each line, and then you access each word. So you have a counter similarly as you had in this. So you increment with every word you're accessing, and then print the final value of that word, final value of that counter. Okay, so this is a homework, but just to tell you, write a program to find the longest word in a file. You can, it's a very easy thing. I've already told you that how to access the word. Now, what you just need to do is, whenever you're accessing a word, just put the length function in that, like we did yesterday. Okay, length of any list, length of any string. So just put the length function in the word. Okay, and you just keep storing that into an array, into a list. Okay, and then print the maximum of the list. Okay, so whatever is the maximum. So there is a function called argmax in Python. Just note down this. I'll not do this because it's in a homework. but just note down this. Arg max means, so for example, in your list there are 10 values. Okay, the fifth value is the max. Okay, so if you do max, it will tell you the value. If you do arg.max, it will tell you that the max value is present at the fifth, uh, uh, position. Okay, so argmax is just note this down. You can use this in your homework. Okay, write a program to copy the content of one file to another. This is again very easy, so I'll not go into all these. Okay, now these I've already told you. Okay, import OS. OS is the so example. For example, I've told you about matplotlib package. You know about the NumPy package. Now OS is another package. It is used to know the directory on which you're working, or you want to change directory. People who have worked on Linux, they might be familiar with this. Normally Windows doesn't have this, because Windows itself has a user interface, but for Linux users who are in shell scripting, this is very important, and this is what they use regularly. So OS is basically that system which is able to access all these things. So make dir, mkdir, is means you're creating a new directory. Okay, change directory means you're changing a directory from one directory to other. Get CW, we have already seen. This is the which directory you are currently working in. RM directory is you are removing the whole directory. For example, if you're removing the whole folder, then you can rename. Obviously, if you want to rename the file, you can rename the file. And then removing the file, it means you're just removing that file and not the directory. Okay, so I'll not go into all the details of it, because, so for example, if I run this, it will just create a folder called new folder 4 in my already existing documents. Why? It is because we are doing a mkdir, means make directory. So it is creating a new directory on your particular path. Okay, so for example, if I run this, you see there's a new folder 4. Okay, okay, now so I had already created this, that's why it's not allowing me to create again. If I just write it as new folder 5. Okay, so I'll have new folder 5 here. Got it. Okay, so any questions till now? Any doubts? Okay, now let's get into the real business. Okay, now I already told you yesterday that Python has certain packages which makes your life easier. So these packages have inbuilt functions. Okay, so you need not code each of your functions every time. For example, in Excel, for example, you need to do a lot of things. You get select your data, and then you go to the your charts, and then select a chart. Then you have to put your labels. I mean, it's pretty easy there also, but I mean, it's kind of a user interface that is driven there. Here you don't have a user interface, right? You need to code everything. But having said that, these libraries make your life easier, and they have codes which enable you to plot your. So plotting is very important, because when you're plotting your data, if you're doing your machine learning, you need to know how your data looks like. How, what is the distribution of the data, how is the data what is the correlation of this variable with that variable, and so you need to know those things when you are um, doing your machine learning. So that is, it is very important for you to know this package. Okay, so there are certain different plots which you can plot. You can do a pie chart, you can do a stat bar, you can do a histogram, you can even do a 3D plot. You can do a sinusoidal. I mean, sinusoidal is just a function, so it's a line graph basically. Okay, so yeah, if you go here, okay, on this screenshots, you'll get what all possible graphs you can make out of matplotlib. Okay, now let's see our first chart here. Okay, now just keep this. This is a very important statement. Import matplotlib.pyplot as plt. Okay, now what it means is, so let me tell you. So for example, Python has a lot of libraries, right? It doesn't. It has, for example, if there are 100 libraries in Python, okay, 80 of them are come with Anaconda as default. Okay, 20 of them may you have to install from your websites. Okay, so for example, Microsoft had developed an algorithm. It is called light gradient boosting. So you may need to go to your Microsoft website or GitHub, and you want to install that algorithm package in your Python. But 80% of the packages come with Anaconda as a default. Now, with these 80%, I mean, amongst this 80%, only 20% are already, I mean, already called. For example, sum or averaging or max min. We didn't have to call any package for that, right? We were just doing sum of a or max of a. But functions like these, which are a little heavy in size, it doesn't. I mean, some user may not need matplotlib to be installed. Okay, I mean to be called in as a function in his task. He may be doing something else. So that's why, to keep it light, it doesn't give you doesn't have that package already called in the program, but you as a user have to call in as per your need. So that is the function called import. So import matplotlib. This is the library name, and this is the pyplot. So this library may have n number of functions. Okay, you need not require all the functions right now. So this command gives you the ability to select this particular function from this library, and as PLT means you want to name this as PLT. So PLT is something which is user defined. Okay, for example, if I want to even write plot, okay, or plots, I mean, I need not worry, because this is something which the user is inputting. Okay, but you cannot do a mistake here, because these are the packages which are present in the Python dictionary. Okay, so you cannot mess up with the names of this. Okay, now X is, what is this? We yesterday we discussed, this is a list. Y is a list. Okay, just plt we have called in this function as plt. So plt dot plot, you want to plot X and Y, and then you want to show. Okay, just execute these statements in your notebook, and see how the output looks like. Is it done? Okay, so that's great. I've got yes from Sharad and Sunny. So, so you see, this is a very normal plot with nothing labeled. I mean, you cannot have such a plot and show it to your boss, right? So, I mean, there's no labels and access. So, you need to beautify it a little bit. For example, this is how you give labels to your graph. So, for example, just run this code. Y1 is again a list. You are storing these values. So now you're seeing two plots, two lines in a single plot, right? So your x is there, and then you're plotting x versus y and x versus y1. Okay, so you're using a single plot. So plt dot plot x y and the labeled is first line because you want you want Python to understand which is this line. So you have to mark it. So this can be anything, right? First line, or let's say this is the revenue. Okay, this is the profit. Okay, so you want to give a color code, so blue, red, and then legend. Legend is, I mean, basically you have labeled it, but you're calling that. Okay, here. So legend function means you're calling the legend part. Then you're labeling it with x-axis and y-axis. Okay, so this is x-axis and y-axis. So for example, x-axis is anything like, for example, years in the or let's say market penetration. Okay, y-axis your so you have two things, right? Revenue and profit. So you can have it as dollars. Okay, so and your title is your, let's say, sales. Okay, so you just you can see here how this looks like. Okay, and how you can change the look of your plots. Is this clear? Give me a yes so that we can move on. Okay, now so this is simple line graph. Okay, line plot. What if I need a stacked bar chart? Okay, so here, you know, so x is the data, y is the data, y1 is the data. So you need a plot dot bar. So here you are just doing plot plt dot plot, and now you're doing a plt dot bar. Okay, that's the difference. So that's how you are telling Python that I know I need a bar chart right now, not plot. Okay, and then again you have you are labeling as first bar and second bar, and plt dot bar or plt dot bar, and then you are labeling it as x-axis and y-axis. Then you're giving it a title, then you're calling in the legend. Okay, so legend. So whenever you are doing this, you have to call in the legend. Otherwise, I mean, whenever you're doing a label, then you have to call it the legend, call the legend out. Otherwise, it will not show, and then plt dot show. Okay. So whenever you are doing all these, right, plt dot show, it is actually updating its memory. Okay, so for example, yes, earlier it was plot plt dot plot. Now it is plt dot bar, and then it is plt dot x label, y label. So if I've updated the x label. It was earlier it was the market penetration. Now it is x axis. So these are updated whenever you are writing down this. Okay, so if you execute that, you will get something like this. Okay. So Sunil, color of bars have been selected. You just need to have the same thing. For example, plt dot plot. If you put color as the same thing, color is equal to whatever you want. Okay, you can put yellow, and then you can put color equal to blue. Okay. So colors normally Python gives you default. So for example, even if I don't specify the color here, it will not give me an error. It is so intelligent that it will know that these are two different axes. Okay, so I need to give two different colors. It may not be blue and red. For example, if I do say so, see, so there's a blue and orange. Okay, now if you put some other data also, may put green. Okay, so there's a default assignment. So every axis it is called. So there's a default assignment, but if you want to specify it, then you can specify that. Okay. Now, this is a pie chart. Now, this is very important. So, how can you plot numbers on a pie chart? So, what it is doing is, it is basically it is plotting, and it knows that 2 is, so these are numbers, right? So, Python knows that 2 is twice of 1. So, whatever blue size is there, okay, and orange is twice of that, 3 is thrice of blue, 4 is 4 times of blue, and 5 is 5 times of blue. Okay, so that is how it is doing a plotting. Okay, but if you do in percentages, it will. So it's again the same, right? It's almost percentages. If you add it, so for example, 9, 12, 14, 15. So this is 5 by 15, 4 by 15, 3 by 15, 2 by 15, and 1 by 15. So pie chart will always plot in percentages. That's how pie chart works. Okay, and yeah, now this is your bar charts or histogram. Okay, so bar charts, we have seen stack bar charts here, and now this is an histogram. Histograms. So histograms, you know how it works, right? So these are the ages, and then these are bins you have created. So bins means what is the bucket you are looking at. So 0 to 10 means what are the ages between 0 to 10, excluding 10. Okay. Then the bucket 10 to 20 means what are the how many number in these. I mean how what is the number of people having ages between 10 to 21, including 10, excluding 20. Similarly, 20 to 30, including 20, excluding 30. And this is the frequency. Histogram will always plot you the frequency. Okay, so this is mean three number of people are between 10 to 20, 20 to 30 there are one, there's one, and so on. Okay, and so plot import, this is the common thing. So this is the data part. You have to specify the bins, and then you do a plot.hist. You have ages in your x-axis, my bins on your y-axis, and this width is basically the width of your histogram. Okay, so you can put it as 1 also, and just merge it, but you don't want that, so just keep it point 9 or point 8, whatever you want to do. Okay. This is basically the space between your how much coverage you want to keep between. So if I keep it very little, so if I keep it zero point 0.5, then it will be very narrow. Okay, so I think we are pretty clear till this point of time, right? Okay, moving on. Now, okay, now let's get back to the slides once. So I've already done this. We have completed all these things. Okay, now some of you may have a question that how do you know the legends in Pi, which is what? So uh, labels is my label. So you have to put it manually. My labels. This is a list. Okay. So this list you have to feed in here. So whatever you want to put, and that will show here. Okay. So A, B, C, D, E. Okay. Histograms you have seen. Okay. Now comes a very interesting subject called NumPy. So NumPy, okay, now yesterday we already saw that there's something called list in Python. Okay, so list is basically an array, a unidimensional array of numbers. It can be a unidimensional array of strings, even mixed data types are even possible. But that doesn't help with everything, right? There are many cases where you may need a matrix. You may need let's say three-dimensional array. Okay, so you know when you come with uh, when you start your data exploration and doing projects, you'll start to understand that why two-dimensional and three-dimensional arrays are required. So for example, each row in databases, if you have dealt with databases, each index might have three different information types. Okay, so there is a particular hierarchy involved with that, and so a normal join may not be helpful every time, right? You may need a three-dimensional. So for example, if you're talking about stocks, okay, so let's say one dimension is what is the companies, what are, so you can see that how this stock is competing with the other companies at this present point of time. Then there can be a different dimension where you are seeing how this stock is performing over previous times with other companies. So there can be many dimensions. I mean, it is difficult to ingest that at this particular point of time. But when we discuss more about data, we'll give you an idea how three-dimensional data and more dimensional data look like. Okay, so this is very powerful. It's again, it's kind of similar to Matplotlib in terms that it is coming with the Anaconda distribution. You need not go and install it from the web. It's an open source, and it's for linear algebra, Fourier transformation, and random number capabilities. So, so when you are doing machine learning on Python, you're running packages, right? So when you're running the packages, you're not going into the deeper sense of mathematics that is going behind it, but someone has created those packages, right, which we are using for our own for our benefits, right? So when this guy has prepared the packages, he or she has done a lot of mathematics behind that, so that engine has a lot of maths in it. So this guy has used NumPy. Okay, so you may not be using it on your end, but the guy who has built those packages has used NumPy. So that's why it is important for us to learn about it. Okay, now let's go back to our notebook. Okay, so import NumPy as NP, the same thing that we did. Um, Again, NumPy is the name of the package from Python, and NP is something which you want to save as a user. Okay, so your first array A is np.array12345. This is a unidimensional array, kind of a list. Okay, and then there's a bidimensional array also. So np.array12345 So 1 2. So if you know in terms of matrix, so this is kind of a 3 cross 2 matrix. 1 2. So first row has 1 2, 2 in the second column. 3 4 is in the second row. 3 in the first column. Fourth in the second column, and so on. Now, since it's a bidimensional array, you need two indices to address each number, right? So 0 1 means 0th row and the first column, or the second column in terms of actual. So 0 means 0th row, these two numbers, and then you are accessing the first one. It means second in terms of Python. You are accessing 2. If you print it, then you get 2. Okay. Okay. Now there's something called size. Size means what is the net number of elements in that array. Okay, so for example, if it's a 3 cross 2 matrix, then you have 6 elements in that. If it's a 4 cross 3 matrix, then we have 12 elements in that. And then you can see the shape command which gives you the shape of the matrix. So 3 cross 2 is the shape. Okay, so 3 rows and 2 columns. Are we clear at this point? Give me a yes on the chat box. Okay, so Neil has sent me a yes. Krishna and Sharad, how about you? Okay. I just noticed yesterday I was going through my recordings. So at some point of time, I was not able to hear you guys. Someone, I don't know who had a question at that point of time, but I just couldn't hear you. So I'm very sorry for that. But so if you have any questions, unmute yourself and you can talk. Or if you want me to unmute you, just ping me and I'll unmute you and then we can talk. Okay. So just keep that in mind. I may not sometimes hear you because of some, I don't know which, some issue. Okay. Now. Uh, So again, we are doing okay. One more thing I just wanted to let you guys know. So I don't know whether you have already figured that out. So for example, when you are writing a code, you need your code to be very clean, right? So for example, why have created such different sections, right? You see, every section is in a different code. It's easier to understand. So if you need to add another section in your code, just go here, click this, it inserts a cell below. Okay, now you may need to give a heading to that. So just go here and do a markdown. You can just write your heading. For example, learning. Okay, and then you can add the cell here, and you can go and do a code, or you can, if you do a code here, then it will just give you an error. Okay, so just this is something which I just wanted to tell you. And if you want to remove the cell and just remove, you can remove it from here. Okay, so it just gives you a clean code, and so that you can understand. Okay, so where were we? Okay, yeah. Now, so np.linspace is linear spacing. Okay, so you want to break 1 to 5 in 10 equal buckets. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are 9 buckets in between. So you want to break them, and that's how it has printed this thing. Okay, okay. So I think we are pretty good on this. Just So if you print your array, then it will print the whole array. If you want to access the first element, you do 0, same as list, what we did yesterday. 0 to 3, then it is 0, 1, 2, excluding 3. Okay. Then now let's go on to the 2D NumPy array. We have already seen that. Uh, so for example, if you have a two-dimensional array, then you want to print that, and then you want to. So now just see this. If you do a print array 0, a0, okay, so Python knows that your this is a two-dimensional array. Now if you just give one index, it will print the first row. Okay, so 1 2 will be printed. If you give 1 to 3, it will print 1 and 2. Okay, but it will print the whole row. It is not sorry, it is not understanding that you want which number of these you want, because you have not mentioned here. So if you want to access 2, I've already told you, right? So if you want to access 2, you want to keep 1 here. Okay, that what we saw in our Anaconda notebook. I have done this. Nothing special here. Okay. Now there's one problem with NumPy, right? whenever you're declaring an array, for example, in list, what we used to do, we had a very simple code, right? For example, let me write it. I'll just put this here. This is what we were, declaring the list with. So a list can be variable. It can have multiple inputs. It can have one input. You don't need to specify your this thing, right? You need not specify anything, any value in this. You just need to declare that. But NumPy has this problem when you're declaring it an array. You need to specify the size of that array. Okay, it's not a variable thing that you can put. So np.zeros is just declaring an array with zeros, all zeros, with this size. Okay, 3 comma 4, 3 rows, 4 columns. Once, you can also replace that as ones. So why these functionalities are given, why is ones and zeros? This is basically, um, again, when you're doing machine learning, it has a lot of matrix multiplication involved. Okay, the matrix multiplication needs to define a lot of zeros and ones if you want to do your matrix operations. If you know the identity matrices and the one I mean matrix of ones. So basically, it helps a lot there. That's why these functionalities have been given as default in Python. np.range, I think it's kind of similar to the range function that we saw in list yesterday. Okay, so for example, 1, 2, 3, 4, 5. It is starting from 1 to and ending till and going till 5. Okay, linear spacing we have seen. Okay, so we have already discussed this. Now, reshape. Okay, now this is very important. So for example, you have a unidimensional array. Okay, so for example, you have 1, 2, 3, 4, 5, 6. It's a linear array. You want to make it in form of a matrix. So just array a dot reshape 3 comma 2. So you are reshaping this into 3 cross 2. So 3 rows and 2 columns. Okay, and then you're printing this. So 1, 2, 3, 4, 5, 6 is a linear thing, and then 1, 2, 3, 4, 5, 6. Any questions till now? Okay. So we'll continue. Now, revel is just the opposite of shape. Okay, so you have shaped your array to some particular dimension. Now you just need to flatten it. Okay, so 1, 2, 3, 4. If you revel it, it will just give you a single linear array. Okay, I hope you have understood how this filling starts. So it will always fill by rows. Okay, I mean it will start with row 1 and then fill up the thing by column, and then second row, then fill up by the column. Okay, so and you can even change that. Okay, whether you want to fill that by row or fill by column, that is also option there. I'll show you later. But that there's an option there. So but revel is basically you want to flatten the array and make it linear dimensional. So operations, I mean, is the same kind of operations that we saw for lists, sum, min, max. Okay, and then okay, now this is very important. For example, if you're doing a sum, uh, the axis is basically whether you want to sum it over rows or if you want to sum it over columns. Okay, so for example, if you have a 3 cross 2 matrix, it means 3 rows and 2 columns, and you sum it over columns, so it will give you 3 values. Okay, so first row will have an addition of the first row first column and the first row second column. Similarly, the second row will have an addition of the second row first column and second row second column. Are you guys understanding this? Okay, let me do this. Sure, I'll show this. Just whenever you do your programming, just keep a check on the uh, brackets, which one has a curly bracket, which one has a double bracket. Sometimes it gets confusing, so it gets, yeah, easy with practice. So you have seen 1 1 1. So there's a 3 cross 4 matrix. Okay, now let's see this. A dot sum. Okay, will go to the column. So axis dot zero. Okay, axis dot zero. It means, so what it has done is it is summing over the rows. Okay, so you had 4 columns. It will retain the 4 columns. Okay, 1 2 3 4, but it is summing over the rows. So 1 2 3, 1 2 3, 1 2 3, 1 2 3. Okay, for if you change this to 1, what do you expect to get? Can I just see the answers on your chat box? That's right. 4 4 4. So it has summed up over this and this. Okay, so this is how it works. Square root of array, and so each of the elements will be square rooted. Array plus array, each of the elements to this particular will be added. You need to have the same shape. Array into array, it's a matrix multiplication, and array into 2 is doubling up the arrays of that numbers of that array. Okay, I just take a 1 minute break here and come back. If you have any questions, just think over it. I'll just come back in 1 minute. Okay, I'm back. So any questions now, till now? Okay. So I've already seen this. This is the same what we learned in list, accessing the first element from the last. Array 1 1 is basically if you have a two-dimensional array, and you want the second element from row and second element from column. So this is just subsetting. If you want x, uh, what are the values which are greater than 3, and then whichever positions they are, you just want to do -1 here. So, so for example, if you want have this, so for example, you have this. This is a two-dimensional array. Okay, so you if you access the first element here, then you'll get 1 2. If you access 0 to 2, then you'll get 1 2 and then 3 4. Okay, and then if you want to access the last element from, I mean the first element from the last, so it means the last element, so it will get 5 6. And then if you want to access your second element of the row and second element of the column, then you'll get 4. Second row element of the row and second element of the columns, 4 here. And then you want to take those positions where array is greater than 3, and then there in those positions you want to replace with -1, and so you will get 1 2 3 4 was greater than 3, 5 is greater than 3, 6 is greater than 3, and then hence we have -1. Any questions here? Okay, so this is your homework. I think well, it's easy to do this, not a problem. In case you have any doubts, we can discuss next time. Okay, now let's go ahead. Pandas. Pandas, it's a funny name, but equally powerful. Pandas is basically what you see in Excel. Okay, a much more advanced version of that. Could you please download and share so that we'll be on the same page? Yeah, yeah. We'll read the file and front. Okay, you want me to download that? Okay, that will. Yeah, yeah. So I'll ask after this session. I'll let Ashok know, and we'll send you the file. Uh, so basically, the objective behind this was also that you can also start looking into Google and how yeah, your Yahoo Finance looks like, and because stock prices is very interesting. But having said that, if you require, we can. I mean, it's not something we want to compare or test you. Just for you to go through the site and you download. But we can send you the data. Let me talk with Ashok, and I'll send you. Okay. So pandas, it's basically, as I told you, that it's kind of a data frame and in Excel. So let me tell you upfront here, pandas is very important, and every algorithm that we'll be doing in machine learning will be dealing with pandas. Okay, and it's basically a advanced version of Excel, but somewhat it is it is a more powerful tool than Excel. A data frame is a two-dimensional array. Okay, so how is it different from NumPy? Let me show you here. Okay, so NumPy has a particular indexing that is followed. Okay, so if you see on the left, your axis 0 has 0 1 2, its axis 1 is 0 1 2, and then but however, if you see pandas, you need not specify any index. It's kind of an Excel sheet. So you have rows, you have names on your rows, and you have descriptions on your columns, and then there's the data. So index and columns. Okay, now there can be even hierarchical indexes. Okay, so for example, one index can have 3 indices inside, and so on. So let me show you how your pandas data structure is made, and let's see here. So import pandas as PD. So I think it's pretty similar to what we have been doing for NumPy for mat.lib. So just import pandas as PD. Let's go to the notebook and let's do this. Okay, so df is your data frame, and this is the name of the data frame that you will be storing. PD dot data frame. Okay, so you're telling Python that whatever we write here inside the brackets, I want that to be in a data frame format, which is of this PD function. Okay, now you can also do one thing. So for example, if you don't want to mention a name of your own, just import pandas here, and then you can also write pandas here. Okay, so it's up to you, but everyone prefers that all the packages that are being imported have some kind of an abbreviation so that it's much easier to write everywhere. Okay, so pd dot data frame, and then you specify all these values. So you start with a double bracket, and then you specify 1 2 3. Then you start with another bracket, then you specify 4 5 6. Okay, now see this, you have to specify the indices. Okay, otherwise Python doesn't, if you don't specify the indices, that is even, that is okay, because that's then in that case Python will assign default indices of numerals, integers, what we say in NumPy. But if you do, you can, if you want to do, you can. So we have declared the number, then we do index. Okay, so we have a, then we'll write b. Okay, now see here, you need to also specify the column. So you're creating a data structure. Now don't think like, whenever you are going to start with data, so for example, if you have a 2 GB data which has 1,000 rows, you have to specify each of the columns, or you are specifying each of the indices. If it is a, let's say, a 10 lakh row data, you need not specify indices every time, right? So normally what happens when you're trying to import an Excel sheet or a CSV file, the Excel sheet will have some headers, or for example, even when you're downloading a date from a database, right? So every row, every database has an index on the row and naming on the column. So when you are importing that into Python, it will be imported in that same format. Okay, you need not always define everything, but this is how you define, if you're going to define at all. So and then you have columns. Okay, columns, you can specify whatever you want. You want, let's say, columns call 1, then call 2, and then call 3. Okay, one thing that you have to keep in mind, you, yeah, yeah. Sunil has a question: is there a way to directly import data from a database into Pandas? It is, obviously there has to be a way. Otherwise, it is very difficult for anyone to specify each of the data numbers. So, for example, a very simple thing, a simple way is to, so for example, when you are importing a data from, let's say, your data working directory, right? So I have, let us show you the working directory. So for example, these are the CSV files in my working directory. I just need to write here pd.read csv. Okay, I'll show you that code, and then just mention that file name, and it will be imported into pandas directly as what it was in Excel. Okay, this line of code, whatever I'm showing you, is just to give you the knowledge that how you can define a data frame. But in your day-to-day work, you need not define a data frame always. I mean, you don't have to do, you just connect it to the database or source file, it'll easily understand what you're trying to do. Okay, so so then if you print it, this is what it will show you. Okay, now let's see. Okay, now you have this particular what say a way where you can access the integers, or I mean the characters or integers or numbers, whatever there are in each of the addresses. So obviously you can see here, to access 2 you just need a and call 2, right? Or you need the index 0 and call 1, I mean the index 1. So uh, data frames will give you two options to access any of the address. So for example, if you want to access via indices, then you have to use df.iloc 00. If you want to access through you know names, then you have to just give df.log a, whatever name you want to put, and then call one. Okay, so just let me show this in our notebook. So for example, I want to, uh, you know, okay, I think this particular value. You just need to keep in mind what is capital and what is small. So Python is case sensitive in terms of functions. So just keep in mind whatever want to access. You see here, if I put this, okay, it doesn't work. Okay, um, you need to put this command df.ilog. So for example, when we were accessing numpy, okay, so we were just trying to input the index of the particular location what we were thinking, but I just wanted to show you in data frames it doesn't work. Okay, so you always need to put this if you are trying to access through this thing, I mean through names, or if you want to access it through indices, then you want to put ilog, and vice versa don't doesn't work. So if you put ilog here, this will give you an error. Okay, so just keep that in mind. Now for example, if you want to see a particular row, okay, you just want to see the a row, then you just put it like this, you'll see all the columns in that particular row. If you want to see a particular column, then you just put it like this. Okay, so this column is there, and whatever if you put I mean if you keep something blank in either side of the commas, it means that you want to see each and every value of that. Okay, so if I put the rows empty, I want to see all the rows in this particular column. Okay, where it is it working. Yeah, so I think you need to put this also. Okay, so just put a colon here. So normally, so whenever you put this on either side of the commas, it means you want to see all, and then you can do a subsetting, right? So for example, you want to see multiple columns, or let's say you want to see just column 1 and 3, you can mention that here. Okay, so you can do multiple iterations with this, and then again, if you put it in terms of indices, okay, I log, uh, you can put the numbers as we used. For example, if you want to see the first row, and I think I have to insert on. Okay, you can put 0 to 2 and then execute this. Okay, so it's up to you how you want to do it, and that's why Python is very powerful in terms of these data frames, which give you a very high flexibility in accessing each of the data points. So I think we are pretty good with this. Any questions till now? Okay. So I think we are pretty good with this. Okay, now one of the very important functions called df.reset index is, for example, there's an index which we created right now, right? There's A, B, C here. Okay, but at some point of time down the line, I may think that I may not require these indices. I just required what Python has in default. Okay, so this reset index, what it will do is, so just note this down, huh? Reset index and this level 0. This level 0 is again telling whether you want to reset the index of your rows, or if you keep it as level 1, then you want to reset the index at your columns. Drop is equal to true means whether you want to keep your original index, whatever you had assigned, you want to keep it as such, or you want to get rid of that. So if you keep drop is equal to true, it means that ABC will go away. Okay, it will only have the reset index, and this will be sequential. There will be no manipulation with that. It will just be sequential 0, 1, 2. And if you drop it, then AB what C whatever you we had created there, it will not be existing. Okay, and then okay, so we have this, and if you keep drop is equal to false, then this index will be there in your data frame as a part of the data. Okay, now for example, for sometimes you want to rename your columns. So for example, in machine learning, there's something called feature engineering. So when you when you change your features, uh, you need to rename them sometimes. So your this is what your new columns. So you just create a kind of. Can anyone tell me what is this? We discussed this yesterday. Can anyone tell me? Give me an answer. What data structure is this? Excellent, Sunil. That's a dictionary. Um, so you have a key value pair, and you have this curly braces, which gives you a hint. So you just what you're trying to do is whatever this key is your original data name, and new column one is basically your new name. Okay, so you want to put column one to your assign a new name, new column one to that. Column two, you want to assign new column two to that, and then henceforth. So df3 is your new data frame. df.rename is your data frame, original data frame has to be renamed with the columns taking the values. This columns is a parameter and this new columns is a feed to the parameter. So new columns will be fed into this columns parameter and it will be renamed to these. Okay, so I think there's no confusion with this. Okay, so this is very important here. This is, if you just click on each of these, you'll get how, what is the header. For example, if you're reading a CSV file, you need to put pt.read CSV, and if you're writing, so pt.toCSV. Just forget the two part right now. So pt.read CSV is basically you're reading a CSV type of file format into your data frames. JSON is a JSON file format, HTML, and so on. Don't interchange any. I mean, it is not interchangeable. You cannot have an SQL file being read in CSV format. It will give you an error. So just keep this in mind. So I, so it will depend on your file type. If your file type is Excel file type, it will not go into CSV. Okay, so you need to convert your Excel first to CSV and then read in pandas. Okay, so example, if you want to read this file, so this is available on Google. pd.read CSV. pd is the pandas data frame. .read CSV is a function, and it is storing in CSV df. Okay. Okay, cs vdf dot set index. It is so what we are trying to do is, this is your data, okay, and you are setting the index with the date. Okay, so as we told you that someone had a question whether we can download the data from a particular database. So for example, this is your database, you have connected to this path, you're downloading the file on this. Now you see, this is the data. So these are the columns: date, open, high, low, and these are the rows. Okay, now you want to set the index with the date. So what you do is, you just set the index, set underscore index with the date, and so your index becomes the date. Okay, so if you now want to access, you want to go with 0 to 5. So I guess if you do this, then it will just print you the first 5 elements of the data. Okay, so I think this is pretty, we are pretty good with this. Okay, now we'll just go into a little bit briefing about machine learning. Till now, do we have any questions? Okay, so Neil has said he's cool with this. Sharad, fine. Krishna Kumar, okay, he's fine. So we also have a module on statistics, but since statistics is itself a long journey, we'll not incorporate that. And since we have already done a lot of maths and data frames and all, so let's go into the real business what we will do in this course, so that you don't you get a kind of a feel of where we would be heading to. Okay, now
before going
Yeah.
going ahead, I have one question.
Yeah, sure.
So we have learned this NumPy and other to pandas and
Yeah.
so what is the use of that in our journey basically?
Exactly.
Could we give us a simple example basically?
Okay. So let's see as data frames. For example, um, you're trying to what you're trying to do in machine learning, right? You're trying to form a model. So when you're forming a model, so you're running that model on a good amount of data set. So for example, a sample data set may have 10,000 rows and let's say on an average 10-20 columns. Okay. Now to make understand the model, that how the data is to be fed in. Okay, how will you feed the data into the model? Okay, the model has to understand some structure, right? That's where the structured data machine learning comes into picture. You need to feed in some structure of the data, and you need some indices and addresses of the data, so that your model can access those, right? If you don't keep a data structure and you feed into the model, how will the model understand that, okay, this particular row is about an user named Shubhadeep, this particular row is about an user named Sunil. Okay, so for example, it has let's say the user database of how many people have undertaken MCAL's PML course, right? And we want to predict what is the interest of the people which who are coming from this particular background. So let's say you have so many data of the customers who have previously come into this course. You train your data. So this data will be trained by a model, and the model has to work on a particular data, and that data has to be structured in such a way so that the model can access each of the elements. If you don't have addresses of elements in your data, it will be very confusing for you and the model to understand, right? So when
So we,
yeah,
so- sorry, please go ahead.
no, no, please go ahead.
Okay. So this is as like a storing of data in memory. I mean, still we have not learned the model. Am I right?
Yeah, yeah, you have not gone into the model yet. You're just giving you the a brief introduction of how Python works. See, you may not be using NumPy as calculations, but the packages that your models will be using, right? That you'll be using for the models, those packages have inbuilt codes. So, for example, when we go into the model part, right, you'll start understanding why we have used, told you about data frames and
Yeah, that's basically I want to learn basically as like a math totally we learned for creating bar chart whether this is required and if required when and how it will be required.
Yeah, yeah, yeah. So that we will tell. But this first and foremost thing that I told you when we introduced the matplotlib, right? As a data scientist, you need to see the data first. For example, someone had asked me yesterday that whether there's a particular answer to all of the solutions in modeling, right? So there's no particular answer to any of the data sets that this model is the best. So you have to see your data. Every data has different assumptions. Every data has follows a different distribution. So first you need to visualize the data, how your data looks like. From that, you start fitting your models. Okay, so when you are trying to visualize your data, that's wherein your matplotlib comes into picture.
Okay. So two things basically. Do we have an example
Sorry?
from which we can use Mathlib and do we have any example
Yeah, yeah.
from which we can see, okay, this is the bar chart or pie chart we are getting, and as we have visualized, we can select, okay, this is the column or this is, I mean, attribute which we need to care of.
Correct, correct. Yeah, yeah, we will have that particular part. Everything what you are asking will be covered in the modeling part, because in the modeling only you will require those visualizations.
Okay.
Okay.
Okay, that's, I'll wait for that, yeah.
Yeah. Okay. Thank you. So let's go into machine learning. Okay. Now, machine learning is basically of two types. Okay, regression and classification. Now let's understand each of these separately. Regression is wherein you're trying to predict a continuous variable. Okay. Okay. Now, what you're trying to predict is, let me show this. For example, um, you want to see that what is the outlook of the weather, what is the temperature, and whether it is windy or not. Okay, and you want to predict whether you want to go to play or not. So let's talk about supervision. Okay, so you already have this data. You already have this data. This data has been supervised by someone who, I mean, it can be from your past experiences, but someone has supervised that when outlook is sunny, when the temperature is 85, when it is windy, when it is not windy, I'll not go to play, or someone doesn't go to play. When it is sunny, when the temperature is 80 and it is windy, I'll still not go into play. So someone has done this supervision. Every particular row has a particular output assigned to it. Okay, and how does this output look like? This output is basically yes or no. So it is of two classes, whether I want to play or not, don't play. Okay, there's no third thing about it. There's not no maybe. Okay, so there's just two outputs. Okay, so this is called a classification problem, which falls under the supervised machine learning techniques. Supervised, I'm again telling you, supervised is something which a person has already assigned a value to the previous inputs. Okay, so when you are learning from your experiences, you know all these experiences have occurred in your past, and based on the new parameters, for example, if someone tells you it is rainy, the temperature is about, let's say, 40 degrees Celsius, it is windy, and windy is true, whether you will go into play or not. So you have seen this rainy, but you have not seen a 40 degrees temperature. Okay, so you want to predict that whether you want to go and play or not. For example, if someone asks you if it is rainy and the temperature is 70 and it is not windy, it means windy is false, whether you will go to play or not, you simply have an answer here. Yes, I'll go to play because I already know from my past experience. But the challenge will come when you see a variable, I mean, you see a temperature which is not in your database, or you see a outlook which is not in your database. Okay, that's when the challenge comes of machine learning. Is this part clear? This is a very new thing for everyone, so I'll be very going very slow on this, and you stop me whether you want to discuss this more and want to know more. Okay, so if there are no questions, I'll just go one step ahead. So we have understood that play is a binary outcome, whether we can play yes or no. Now just go back to your previous slide. What is a regression? Same thing. Okay, okay. Let's go back to this example. Okay, I think we don't have that example here. Okay, now, okay, I'll give you an example of my own. For example, if you had this problem, outlook, temperature, windy, and you want to check how many children are coming out to play. Okay, it's not just about a particular binary variable output, whether it is yes or no. We want to check whether how many children, how many people are coming out to play. Okay, so it can be one, it can be two, it can be thousand. It's a continuous output, and since it's the number of children, it is ranging from 0 to infinite. It can be any number between that. So that is a continuous variable, and you want to predict a continuous output. Okay, so that particular type of problem falls into the regression problem. Okay, supervised learning. So we have discussed classification, we have discussed regression. I'll reiterate again. Supervised learning is a type of learning where your data has been pre-marked by an expert or pre-marked by a past experiences of whatever you have seen. And a classification problems is a type of a supervised learning problem where you want to predict an outcome which is of a binary or multi-class. Okay, you can also have a multi-class. I mean, let's say yes, um, okay, let's say movie ratings. Okay, movie ratings are one IMDb rating. It says it can be okay. Let's say about okay, yeah, IMDb rating 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it can be in points, but we'll discuss when we discuss statistics. You actually do, there are four types of variables: nominal, ordinal, interval, and ratio. We'll go into that, but for now you just understand that classification problems have a set number of fixed outcomes. Okay, your outcomes can be of that range. For example, IMDb rating can be somewhere between 1 to 10. Okay, I'm not talking about an average of movies that can be different, but for a single movie, let's say we are having IMDb movie ratings from 1 to 10 and not going into points. Regression is a problem, let's say price. If you want to um, calculate the price of a house, so you have X number of features, you want to predict whether the price of the house is 24 lakhs or if it is, whatever number you want to predict. Okay, the other same example can be whether this house falls into the high category of cost expensiveness, if it is in the medium category or in the low category. So he has fixed three outcomes. I think this is pretty clear. Now, what is unsupervised learning? Unsupervised learning is a type of learning where there is no particular supervision to the data. Okay, so for example, where we saw here that someone has told that there was play when this was the condition. I mean, there was no play when this was the condition, and there was play when this was the condition. Someone has already told. What if you don't have this column and you don't know what was the state? Okay, so for example, let's take a very simple example. For example, if you have plotted a lot of data on height and weight. So, for example, you were sitting in a clinic, and for 3 months you have noted all the people's height and weight, keeping your eyes closed. You never knew that whether it was a female or a male. Okay, so just think supervision is that you have each of the guys' names and their gender, and you have their height and weight. Unsupervision means that you have noted the height and weight, but your eyes were closed at that point of time, so you don't know whether it was a male or a female. Okay, so what do you do with unsupervised learning? Certainly, if someone gives you another height and weight, you will not be able to predict whether it's a male or a female, because in the first hand only you never had that data, that who is a male or female. So how will you even tell that guy whether this height and weight belongs to a male or female? So that's where the clustering part comes. Okay, so we'll not discuss clustering right now because that will be dealt in much detail later. But just to have an idea, clustering is grouping of similar things. So for example, if you plot all the height and weight of the people that have visited the clinic for 3 months, you'll see a separation. Okay, so some people will have a height and weight to the upper side, and then some people will have height and weight to the lower side. Okay, so you probably could figure out that, okay, there are two groups forming in my data. Maybe the higher weight and height is male, and the lower height and weight is female. Okay, but that inference or that insight is up to the user. Okay, data will not tell you what is male and female. That interpretation is from by the user. Okay, we'll see how clustering helps in machine learning, but for now it is let's keep it to that. So I've already told you this, so just go by the definition. If you're training your algorithm with observation which includes the outcome as a part of the input data, it is called supervised learning. So we have told this. Okay, now in machine learning there's always a universal truth, or you could say the ideal function that is predicting your output. Okay, so for example, if you uh, if you're an atheist, you want to believe that, but I mean, if you believe in God, you'll probably think that God knows everything about this universe, right? So there's a particular function which has been used to calculate the heights of males and females, or that's how God has made us, right? So He'll know the proper function. But we as humans, we don't have that function, right? We don't know what God has used to calculate the height of males and females, height and weight of males and females. You can only learn by yourself from the data, whatever you are seeing in this universe. Okay, so G is a function which is your guess. So your what is your aim in machine learning? The main aim in machine learning is to get G as close as possible to F. Okay, if you do a G equal, I mean, if you get your G equal to your F, then you have solved your problem. But obviously, every time you cannot go or take your G to your F, right? There has to be some error because you're not God at first. The first thing you should know that you're not God. You don't know what function has been used in any of the cases, not just height and weight of males and females. So your aim is to go as close as possible, and that's why we have this notion of having the least possible error. Okay, so we'll go come to this later, but this is how. Okay, any questions till now? Okay, Krishna Kumar, thank you so much. Sunil, Sharad. Okay, now let's see into regression. Okay, I've already told this. Y is a number and G is the function. Classification, it is a suite of algorithms that specialize in machine learning where the outcome is a list of values. Okay, the features of the data, outcome of the data, and then your hypothesis or the guess. Okay, so I tell me the answers of each of one. Okay, we'll start one by one. Email is a spam or not spam? What is it? Is it a regression or a classification? Send me on your chat box. Sunil says regression. Krishna Kumar says classification. Okay, Sunil has corrected classification. Sharad classification. Perfect. So email is a spam or not spam? It means we just have two outcomes. It can be a spam. It can be a not. It may not be a spam. So there's no two ways about it. I mean, there's no third way about it. So just spam or not spam. Stock price of a company come 3 months from today. What is it? Regression or classification? Reg. Sharad says reg. Krishna says reg. Sunil. Okay, so I think you get this right. So house price is again a regression. Person is diabetic or not based on blood report. What is diabetic or not based on blood report? It's again a classification problem. Okay, so unsupervised learning is a type of machine learning algorithm used to draw inferences from datasets consisting of input data without their outcome. As I told you, you were supervising with your eyes closed, so you don't know what data it was. So this is what clustering looks like. So for example, when we told that you have plotted the height and weight of males, of persons that have visited in the clinic for 3 months, you'll probably get two groups. Okay, one on the higher end of the right top end, and one on the left bottom end. Okay, there'll always be some scatter. I mean, there'll always be women who are fit, having a greater height. Again, there's something. For example, if you are sitting in a clinic in Asia and you're sitting in clinic in Australia, your values will be different, right? So that's why clustering is not something which will tell you what it is. You just have to figure out on your own, or it will just tell you what is the distinction between each of the, I mean, what is the distinction in the groups. Okay. Okay. So supervised learning is basically they have many models. Okay, there are linear models, there are non-linear models, there are decision trees, random forests, many things are there, right? But um, if you are if you are someone who is beginning with machine learning, there's something that has to do with linear regression. Okay, so linear regression is very important for a beginner to understand properly. I mean to the best of its core, to even go into advanced models. Why am I focusing on linear regression as one of the most important techniques? It will not, I'll tell you right now, it will not solve 90% of your problems, because linear regression is too simple a model to fit in your data. Okay. But linear regression will, why we start, or say it is the hello world of machine learning, it is because it is very important for you to understand the basics of machine learning, and linear regression is the simplest way to understand that. Polynomial regression is another form in advance of linear regression. We'll talk about regularization and ridge and lasso later. Okay, so now let's go into uh, a bit of linear regression. Okay, okay. Now let's say you have a x-axis and you have a y-axis. Okay, now you have typical features of a house. Okay, and you want to predict the price of that house. Okay, so someone may have a $3,000 $300,000 price, someone will have $100,000 price, someone will be having something. So let's say if you are just taking the size of the house, so let's say if someone is at around 2,000 square feet, the price is $300,000. If someone is at let's say 600 square feet, then its price is $100,000. And if someone is around 1,200 square feet, it is around $190,000. So now, just follow me very slowly here. Each of these squares, okay, what you see is the data that is being plotted. Okay, whatever data you have in your data set. For example, you may have data for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13 data points are there. You're plotting it here. Okay, so one here, one here, one here. It's just a basic plot, nothing fancy about this. Now your objective is to predict some house. For example, if there's some house whose size is somewhere around let's say somewhere around here, what will be the price of this house? What is your best guess here? Okay, you need to understand how is this line is made. Okay, I cannot fit an orbit line, right? I just cannot fit a line. I mean, does it make sense to fit a line going through most of the points, or I mean, should I make a line which is closer to the maximum number of points? So linear regression is basically your line is being constructed accepted based on the root mean square error. Now, what is a root mean square error? It is basically that, for example, you have a line. So for example, at this particular point, you are putting the input as 1500 square feet, and there would be a value on this line, right? You want to put this line in such a way that your errors is the distance between the actual data and your line. So actual data and your line, actual data and your line, actual data and your line is minimized. So whatever, so for example, this point, drop a perpendicular from this line to your line here. Drop a perpendicular, not exactly perpendicular. You drop this, right? Drop a line from here. So whatever value it is at this point minus this point. So this point is, if you drop a line perpendicular to your x-axis here, it will cross the line here. So this particular point will have a value, and this point has a value. Okay. So what is the difference between this value and this value? That value squared plus this value squared plus this value squared plus this value squared. So you're adding up all the differences of your 13 data points. You're adding up, and then you're minimizing that. That minimal error, whenever you are having, is a line which is made here. I guess it is. I think it is not clear for everyone. Can you give me a yes or no on your chat box so that I understand if I have to reiterate this again? Sharad is fine. Krishna is also fine. So Neil, do you need me to uh, reiterate this again? Okay. So Sunil asked a very valid question. He says that the square root error, he's clear with that. But without knowing the slope and why, how can I do this? And that's a very good question. So Sunil, there's something called when I'm assuming that this is a linear equation, right? So I'll have a slope of the line, and then there will be an intercept of the line. So y is equal to mx plus c is the usual linear form of linear form of the line. What you need to do is you have this value at here. You know this data. You know when you put y is equal to mx plus c and you put the x value, you know m into x plus c. Okay, that value is, you are not knowing that. Okay, so what you have your function as this value. For example, this value is 100,000 minus and let's assume this is 500. So 100 minus 500 m plus c square, that is your this distance. Similarly, this distance is that minus 600 m plus c. So you have so many points with just two constants, two unknowns, m plus c. When you try to minimize that whole function, you are just having two constants, two variables or two unknowns. When you minimize that, you will get the value of m and c. Think like this, right? There will be one line which is going through the not middle, but which is having the least error. Sunil, you are asking something?
Yeah. Yeah. Could you write this equation somewhere so that we can see?
Okay. I'll write this.
Yeah, linear regression, that's clear. Y equal to ax plus b.
Okay. Okay, so this is your ax plus b. Okay, so this is your y pred, what you're trying to predict, and then there's y actual,
Okay.
right? Now I don't have the sigma this thing, but I'll just write in.
And
I write it in words. Sum over whole data y actual minus y pred square. This is your function, and you want to minimize this function. Does this clear your doubt?
yeah, y actual we have and y predict we don't have.
Yeah,
We have x only for that. A and b are unknowns.
I know. So you know differentiation. So when you have a function,
Yeah, I know.
this is second order function, right? So when you are trying to differentiate this equation, so your c's will cancel out because c is a constant. So you just have that slope to play with, and when you differentiate, okay, you have that slope that will come out here. So we'll go into stochastic gradient descent when we are trying to minimize this. We'll understand this function there better, and how we minimize this. But just keep this in mind, that this is your function which you are trying to minimize, right? So there will be two. This is a second order differentiation. You'll get one. So you can, whenever your function is there, you when you need to find the minimum, you need to differentiate it and equate it to zero. Okay, so you'll get one value from there, and then you follow the stochastic gradient. So we'll go there and see how stochastic gradient works. But for now, is it clear?
Yeah, this is clear that there will be some imaginary line
Yeah, yeah, yeah.
for every x, whatever y we have given. We have to take the square root and we have tried to minimize that.
Yeah, that's the difference between your actual and prediction. That difference is to be
Okay.
minimized.
Okay.
Oh, okay. Let me show you more, you know, visibly. Okay, what you can do this line, you can tilt this line. Okay, you can tilt this line clockwise, anti-clockwise. You can make this line up or down. So you have two movements, right? So whenever you're trying to move this line clockwise or anti-clockwise, you're changing the slope. Whenever you're trying to move the line upwards or downwards, you're changing the intercept. So you basically have two ways to move this line, right? And using those two ways, you're trying to obtain the minimum distance between these points. Even if you don't understand it mathematically, just think it physically, right? I can move this line up or down, depending, and obtain a particular line, so that I have the minimum distance from each of the points. Is this understood?
So my question is, why linear regression? I mean, in linear regression, there will be only a line. Why not we are going for a curve?
Okay, that's a good question. So that's what I'm
And
telling.
why, yeah, that's in care. Why I mean, that is the question. Why I select linear regression, nothing else.
Okay. Now, okay, Sunil, that's a very good question. Now, tell me one thing. If you guys are good in mathematics, what is the best polynomial order of equation that I can fit into this line? Any answers on that? Does anyone know? What is the best polynomial degree which I can fit in a 13 uh, Sharat?
Definitely not one or two. I think so. It will be more than two.
Exactly. It's a 12 order polynomial. So if a 12 order polynomial I fit into the this curve, I mean all the points will be fit, right? So ideally that is the best polynomial, this best curve I can fit into this, right? Uh,
Correct.
is it understanding? Are you understanding? You can fit a 12 order polynomial which passes through all of these points. But
Yes.
it is very important to know that you are not trying to predict these points. Okay, there can be a point, for example, if a point comes up here, and you had, for example, if a point comes up here, okay, you had predicted, so your polynomial was going like this, okay, so your polynomial was going like this, your point is here, you'll predicting here, what is the error? This is the error. It's a huge error. So there's something called overfitting and underfitting in statistics and machine learning. We'll go into depth there, but for now just understand whatever points there are in your data, you need not fit them all, because if you fit them all in future, if you predict for a different data point, it will give you huge error. Because just understand this, right? If you it's like, it is again, machine learning is not hard coding, right? So if I say that I want to fit a polynomial that goes through each of these points, and then there's a particular point which comes up here, I completely failed in predicting that value, and I'm very far off. Okay, so there's something called Occam's
Mm.
razor in statistics. Occam's razor, it's a very fancy word. When you learn, you can, tell your peers that Occam's razor is a concept where, you know, you start with simple models. To come to your question, is linear regression, the first thing that we should come up with? So told you at the starting only, linear regression may not solve 80% of your problems. First of all, we are starting with linear regression because it is the most simplest form of machine learning, and it will help us understand the concepts. Next, linear regression is being used because I don't know which equation. For example, when we were seeing that f of x, and we were saying that f is being designed by God, maybe f, I mean, God has designed f as a linear problem. Okay, for example, I mean, if you have chemical engineering background, or I mean, if you have a chemistry background, you must have known PV and RT equation, right? The ideal gas equation. Now, what if there's a process? Okay, just think of it like this. What if you have a process where your volume is constant, you have the same moles of gas. Are you guys aware of this equation, PV and RT? I mean, let me not elaborate that if you're not.
No,
Are you guys aware? Give me a yes or no.
no,
Okay, you're not aware. So okay, okay. So I mean, let's not go into this. So there may be processes which are actually inherently linear in nature, and if you start fitting a polynomial in that, you'll actually going to worsen up your prediction. So it's always, ideally, it's always better to start with simple linear models and then go further into complexity. Okay, don't start with a very complex model ever, because you never know what is the actual f that God has designed. Okay, so why we are starting with linear regression is that I don't know that what is the actual process behind uh, how this data has been generated, or how this data is coming. It may be a linear form, and if I start with nonlinear polynomials, I'll not never get a prediction, proper prediction. Okay, so always start with a simple model, and that's why we start with linear regression. Okay, so
okay.
okay, now I will show you this. What is the gradient descent, and you know just first we'll read through this, and then let's understand this. So gradient descent is used to find the minimum error by minimizing a cost function. Okay, think of this as, for example, if you have a bowl, okay, glass bowl or a steel bowl. If you put a drop of water in on your bowl, where will the water drop settle? At the lowest point, right? So stochastic gradient or a gradient descent is exactly the similar algorithm to a water drop trickling on a bowl. Okay, consider this water drop. Consider this the bowl as your function. Okay, the function's lowest point is at the bottom. The water droplet is where you are right now. You're trying to go down the gradient. You're trying to go down the slope to go to the lowest point possible. Okay, so now let's understand this. Did you get a sense of this? Did my example makes any sense? Give me a yes or no. Okay, Sharad says didn't understand. Okay, uh, if I can open Paint and show you. So consider this is your cost function. This is where you are. Okay, so this ball will always settle here because this is the lowest point of the cost function. This is the minimum. Okay, you're trying to reach your minimum. What I told when I was giving you the linear equation plot, I'm trying to reduce the root mean square error. Okay, what I wrote in the notepad, minimum of sum over the whole data actual minus prediction. So this is your cost function. You want to go into the minimum of this. Okay, so consider this cost function as this bowl. You want to go to the minimum of this. Is it better right now? Did you understand? Little bit even, so that I can build on this. Okay, Sharad, he has understood. Krishna and Sunil.
So basically, what do you mean by cost function? The sum of all the square mean error
Exactly, you're
is
getting it.
that?
A sum of all the squared mean error. Okay, I mean mean is
Okay.
after you sum up. So squared mean of the squared error. Okay, root mean squared error. RMSE, root mean square error. First you take a square, then you sum up, then you take the mean, and then you take the root. This is your cost function. Okay, now can anyone tell why we are taking the square and then summing up? Why not taking it, doing it directly?
Because whether that is negative or positive, it will be positive always. Is that
Awesome,
so?
awesome, awesome. So, for example, yeah, exactly. Krishna also answered this correctly. So, for example, if there's a point here and if there's a point here, this will always negate. Okay, so whenever I have points up and above, I'll always get negative, and I'll always get zero error. I mean close to zero error. I don't want that. I want the real distance between the line and the point to go minimum, and not by having minimum. So for example, if a point is here, okay, imagine every point is every point is positive, and then there's a negative point here. Okay, So all the positive added and one negative added will become 0. So I'll get the best line, but that is not true. Okay. So although this is an outlier, will not take into consideration, but just to give you a sense of that how positives and negatives should not cancel out. Okay. So this is how your gradient descent works. So to avoid negative values, we square the distance. To calculate the error, we can take the average of all the squares and then take the square root of it. This is also called the root mean square error. Okay. Now this we have already only uh, talked about, single variable. For example, you can have multiple x's, okay, and you can have one outcome. So these are the coefficients. So when you are doing multiple coefficients, okay, c1, c2, cn, you don't know each of these variables, right? Do you understand that? You don't know each of the variables. So when you are achieving the stochastic, when you are doing the stochastic gradient, okay, now I think it is becoming a little maths heavy. So we'll continue this in the next class, so that you get some time to absorb this equation. But let's keep it till here. I'll go into polynomial regression and overfitting. I can, yeah, okay, just see this, what I was talking about. So for example, this is your data, okay? This is underfitting. I mean, your actual data goes like this, but you have just fit a linear model on this. Huh? This is not even close to what your actual data looks like. This is overfitting. You have fit all the values present, right? Now if you get a prediction here, you'll get huge error, okay, because you cannot overfit all the components here. Okay, this is also called overfitting. Okay, you have fit your uh, data completely. What will be a good estimate is a smooth curve going from here to here, a smooth curve going from here to here. Do you guys understand?
In I mean, why the graph in the third overfitting, that is not correct. It's going up, but there is no any point.
Yeah, so the thing is, see, it is not I mean, it is not a mathematical equation that has been made. It's just to show you what I mean. It even has a break here, so it's not to show you something. It's just how overfitting works. Okay, so don't go by that. It is showing that how you have even uh, fit your point so hard that so for example, from this point to this, how many ways you can go from this point to this? There are infinite ways, right? You can go like this, you can go like this, you can go like this, you can go like this. So there are infinite number of ways you can go from this point to this point, right? So if you overfit it, so this graph can look like anything, right? That's why it is trying to show that your predictions can become very bad if you try to overfit anything. So what it should be is ideal graph, ideal. So if you say that what is the God's function here, the God's function will be like this, smooth curve along this. Okay, yeah, Sunil, you were asking something.
Yeah, because I did a few classes of N2NG,
Huh.
and it was defining overfitting means we are touching every point.
Yeah, so we have touching, we are,
And so that in so in both the cases, second and third, we are touching all the points.
so
Then why third is the overfitting?
no, no, this is also overfitting. It is trying to say how different overfitting types you can have. Okay, so this is not a smooth curve. That's what I'm saying. If you touch all you now see one thing that is wrong in your definition is overfitting is not touching every point. Okay, overfitting. So for example, if by any chance all points lie on this line, right? All points lie on this line, and you fit a linear regression there, Okay, so that is not overfitting. That is what your actual model looks like. Okay, because
Okay.
every point will be on this line. Okay, so your actual process looks like, for example, if I fit a smooth polynomial here, a smooth polynomial, it is the actual function of this process.
Okay.
Okay, so that's what I'm saying. So when if you see, this is what you can summarize in machine learning. There's a god's function and there's your function. God's function can be anything. It can be a polynomial, it can be a linear regression, it can be any function, it can be an exponential function, it can be a sinusoidal function. You never know what god has created that process from. You can best estimate that using your knowledge of machine learning. Okay, now,
So what can be the two-line definition of overfitting and underfitting?
okay, now overfitting and underfitting two-line definition, if you want to know, is based on bias variance trade-off, or let's say I'll tell you in terms of training and test data. So, okay, now let me introduce what is train and test data. I think I told this yesterday also. Train data is something on which you train your model. Okay, so for example, if I go on this, so for example, if this is your train data, these blue points are your train data. Okay, this is where you have trained your model, and then there's a test data on which your model has never seen that point. For example, if you get a blue point for somewhere, for example, if you want to predict this number for 2.5, you don't have the actual data, right? So you want to predict, if this is your function, you will predict here. If this is your function, you will predict here. If something like this is your function, you will predict here. So basically, you want to understand what is the prediction when 2.5 comes, when we have this data. Okay. Now, if you want to say what is overfitting, overfitting is when you have decreased your training loss to zero. Your training loss means your root mean square error in terms of linear regression, your root mean square error, or if you have fit a polynomial, what is the difference between the actual and prediction squared for these data? This is zero, right? You don't have any error in your training, so your training loss is zero. And underfitting is that your training loss is very high. It cannot be infinite. Okay, it cannot be to the other extreme, but your training loss is the maximum. Okay, so we are underfitted. Do you see? So for example,
Okay.
if I fit a line here, okay, here the training loss is huge, right? My data is here and
Correct.
I predict a line here. I mean, I've prepared my g function here, so this loss is huge. So this is what is called underfitting, and this is called overfitting. So overfitting is when your training loss becomes zero, absolutely zero. Okay, now,
Okay, that makes sense.
yeah, now let me make a training test. This thing, you'll understand this clearly. Now this is the loss. Okay, and this is your, let's say, complexity of the model. Okay, your training loss will always decrease with the complexity. Complexity means this is a linear form, and then this is a nth order polynomial. So if I start with the linear form, okay, and increase the complexity, my training loss can be zero. I can fit a polynomial which goes through all the points. This is your train loss. There is a test loss, or the actual loss, you could say. That loss can be like this. So your loss first decreases and then it will increase. Okay, I'll make the test loss separately. So for example, if your God's function is of the order 5, okay, and this is, let's say, 13 order polynomial, and this is 1 order polynomial, your test loss will be high here. It will go to the lowest in 5 and then again increase to 13. So you have to reach this point. So what you need to do with this to achieve this point, you have to start from here and grow from here, or you can start from here or go from here. Normally this is the correct path. Start from here, you start decreasing your test loss, and then once it starts increasing, you stop there. This is your God's function. Got it?
Yeah, yeah, I think so.
Okay.
It's clear. So basically, what we are saying that we have to find a model for a problem so
Yeah,
that we can predict. Is that the part? Is that the machine learning?
exactly.
Okay, and so that model will be some mathematical equation.
Yes.
Okay, and I think so for that mathematical equation, we have to minimize the cost. I mean, RMS.
Sorry, didn't
Is
get
it
it.
that? Okay, so in or that first thing, we have to find out the model.
Yeah,
Second thing, that model will be some mathematical equation
yeah.
of n order. And third thing, basically, that model will have cost function or root mean square as minimum as it can be.
Perfect. I think you have nailed it down. So every model has a cost function. We need to go. We need to have that cost function minimum in terms of testing. Okay. See, again, cost function can be minimum to 0 for training. What matters is that we need to be at the minimum point for test data. Test data, it means new data, something which we have not seen in your in the future in the past. Okay. So this is how what you need to do. You need to fit the model to a particular data set so that your test loss is minimum, and that model will be the best model to predict the future.
Okay, that's great. So can we do this for the example which you shown that in particular size, this is the particular value of that house.
Yeah, we can
So
do that.
taking up this,
Yeah,
yeah, taking that example, what we have to do, we have to find some linear equation right now so that our cost function should be minimum. And that is our main intention to find value of A, X, and X is given. So A and B we have to find out.
perfect. Yes, we have to find out that.
Okay, so my question is that in all this whole story, what is the use of that bar chart and pie chart and other things?
Oh, okay. So, for example, how did you get an idea to fit a linear regression model?
Because I saw dots on my 2D graph.
How you saw you plotted, right?
Okay,
You plotted first. So you plotted
yeah, I thought, yeah, got it.
you plotted a scatter plot, and then you saw that the dots are appearing, and then you see, okay, I think a linear model will be a good fit here. Or if I see this function, I'll immediately
Yeah, it's a
know
linear
that
function or
this is a non-linear function, this is a polynomial. So I think I need to do higher
so
order.
in which case we will go for pie chart or bar chart because this visualization always we can get some point based on some points, isn't it?
Yeah. So normally this you can do bar chart. Histograms, for example, are used for to calculate the distribution of the data, whether it's a normally distributed. So you'll get to understand. Don't try to understand everything today because it will get confusing. You'll eventually try to get to understand why each of the charts are important, and it doesn't mean that we have taught you by pie chart that it will be required in machine learning. Okay, there's some things you need to know as general knowledge also, right? For example, if your boss wants you to present some data, you need to know, if you are using Python, then how to plot a pie chart. It may not be required for your model, but for visualization you need to know.
Okay.
Okay. Okay. So we closed today now. I think we had a very rigorous session today, and we even went ahead of what we planned. I think today was great. So
So one thing, can we get your slides today so that we can go and
yeah,
do some exercises with
yeah.
you?
Slides, I'll send even the videos you'll get today. This video, whatever we have recorded, so you'll get everything today. Today or by early morning tomorrow. I mean, I'll upload it.
Okay. Yeah,
Sure.
yeah, that's fine. Okay.
Yeah. Okay, thank you so much, everyone. Catch up next week. Anyone has any doubts here? Because we have 2 minutes left. Anyone has any doubts I want to ask?
Okay, so timing other than this course basically is that we go in plant. So what machine learning engineer does basically their day-to-day job? Because someone told me that aesthetic is one part. First, you need to understand that. Then you have to code. Someone was telling me both are the same. You can do easily. So starting from the problem, because also in my company there is one data scientist working on R and Python. Someone using Java for coding. So how it happens actually?
So, a machine learning engineer can be of a very different forms. Okay, so he or she can be using R. R is a statistical tool. He or she can be using Python for very advanced predictive modeling. So Java is more of application programming. For example, if you want to develop an app, or if you want to develop something which is more of a application programming, then Java used. But for machine learning, like these prediction models, you need to use Python. And a
Mhm.
typical
Because
machine
the,
learning engineer will be, using Python to develop predictive modeling.
okay, means up to prediction means we can also do data science and prediction both using the Python.
Data science and machine learning is, I mean, it's they are very common. So data science and machine learning, they are not very different. You can call it under the same banner.
Yeah, because so first year, so yesterday also was saying, and you also told that you are very good in data analytics. So just I want to understand what does this really mean?
Huh. Yes,
Because
we'll get to understand what. So, for example, we have done modeling today a little bit. Now, when we go into much deeper sense, you get to understand what data science is and what we are trying to do. But the three-point statement that you summarized with, I think that is a very good definition of what data science and what we are trying to do in machine learning is. And I think it is very two of them are two of these things are very similar. So you don't have a particular broad line to distinguish that. But having said that, we'll get into that eventually. Okay. Okay.
okay, that's great.
Okay. Thank you, Sunil. Thanks for your time. Okay.
Thank you. Thanks to you.
Okay. Thank you so much.
Okay, see you on Saturday. Bye.
Yeah. Bye.